Hello and welcome to the fifth module of Machine Learning and Data Science course. So today we are going to talk about regression, and in particular we are going to be talking about linear regression. So there are various forms of regression, but we are just going to be touching on linear regression, the simple and multiple, both versions of it. Because the idea of this course is to give you a starting point that is good enough for you to build upon concepts that you have already learned from this course. So yeah, just that. So simple and multiple linear regression, we will be talking about that. Then how they work, what is regression, what all these things mean, and how they differ from each other and everything. So after that we'll talk about gradient descent. So gradient descent is one of the very important topics of entirety of data science, machine learning, and even neural networks, because it forms the backbone of how a loss function is actually minimized, what minimizing loss and all these things mean. So yeah, we'll be talking about gradient descent after that. And lastly, a little on maximum likelihood estimation, because it's not that critical of a topic, because even without understanding much of it you can do well, but still, because it attaches itself to the concept of gradient descent and everything, so we'll talk about that as well. Just a little intuition about that. After that, we'll see a very basic notebook on banknote classification. So since I've already shown you some examples of regression, so I'll show you how the formula of regression or regression model can be used to make classifications as well, because the same basic formula can be applied to a classification problem as well. So yeah, last in I'm guessing, yeah, in the second last and last two modules, we have already discussed what is classification and a little bit about what is regression, what is continuous form of data, what is discrete data, and all these things. So yeah, without wasting much time, let's directly jump into it. So what is regression? As we have already discussed before, that regression basically takes a series of input, like something like x1, x2, and continues till xn. So it takes all these values. What it does is it maps all these values, all these inputs, to a specific value of y, because we want to predict the y given these inputs. So we have to find the value of y whenever we get a set of input such as this. So this is basically the problem of regression or regression. What regression techniques do is they find this mapping. So we have been given this set of x and we have been given this set of y, then we want to find the mapping that maps this x to y, so that when we are given a new instance of this particular series of values, then we can predict a new value of y depending on what we have already learned. So regression basically is again a technique to understand or learn this mapping between x and y, means the input and the output. So now, how are we going to get our data? So again, we have already discussed that we'll get our data in form of a table or a data frame and something like that. So we have a data frame. What we have in that data frame is that we have certain features, such as, let's call those features feature A, feature B, and feature C, and feature D. So we have some of the features. So let's call this A1, B1, C1, and this one D1, and dot dot dot. So yeah, let me just clear this. So yeah, we have all these features given to us. So given these features, there's another column or there's another value that is present in that table. Let's call it p, because p is for prediction. So given all these values, we have something p that we want to actually find when we are given these values, right? So p can be, let's say, p1, p2, and so on. All these values we want to find. So if it's a regression problem, what we actually are targeting at something like float value or something continuous value. For example, given the details of the house, we want to find the price of the house. For example, 25,000, something like that. So we actually want to find this mapping between these four and p. So we will be given data in this form, in a tabular form, and we'll have to train our model from this input data to this output data. So now, what does a regression model, what mathematics does a regression model is governed on? So the very basic mathematical formula, which is y is equal to mx plus c, that we have studied in class 10th, 11th and 12th and so on. So we already know this formula, right? So this is the formula that linear regression or simple linear regression basically is defined on. So given a x, what we want to do is we want to find this y. So how are we going to get this y? So we must know a value of m and we must know a value of c. So what is m? M here is the slope, right? So we already know what the slope is. Let's again discuss it. But so m is the slope and c is known as the intercept. So let's assume that there's a graph on which we can plot x and y. So let's say that our data is given such that we have some points like this, right? And then given these points we can actually draw a line. So for example, if just given the value of x and y, we want to find the line. So what we'll do is we'll draw a line that passes mostly through all those points. So as you can notice, some of the points are missed here on this straight line. So, since all these points are not perfectly lined or are plotted on this line, there's going to be an error between the line that we actually draw and the actual data points, right? So what is this error? So this error is the distance between all these points and this line, right? So what we want to do is that we want to find a line, we want to find this line which fits all these points in a way that this distance between all these points, this cumulative distance, for example, if an point is here, then the distance is something like this. So the distance between all these points is as minimal as possible, right? So again, what we want to do is we get a x, we have a y, we can plot all these points, then we can manually draw a line that passes through most of the point or some of the point and is relatively close to others, in a way that the distance between the point and the line is as minimal as possible, right? So let me just get rid of all these things. So now, what is the slope? What is the value of this m? So for example, the last 2 points that there are, so yeah, so for 2 consecutive values of x, right, for 2 consecutive values of x, what is the mean change? So again, the value of m is slope, right? So what is the slope in this graph? The slope is nothing but the value of the 2 values of x, the difference between the two consecutive values of y, that is this distance, and which is divided by 2 consecutive values of x. So it's just y2 minus y1 divided by x2 minus x1. So this basically is m. So is that it? That given 2 points we can just take this formula and find the value of m, because m is the unknown, right? We have y, we have x, we want to find m and we want to find c. So if we have this formula, why do we need to perform any of the operation that we are going to be learning about? So well, the thing is that the entirety of the data is not governed by just two of the points. So the entirety of data is not governed by just two of the points. It's actually defined by hundreds or thousands or even millions of data points, right? So we want to fit our model in a way that given these data points, the error between or the distance between all these data points and the uh, line or the plotting or whatever you want to call this is as minimum as possible. Not just these 2 points, we want to fit it to all the points, that as many points as we can, so as to get better prediction or get better at predicting, right? So this was M. So now what is C? C is the intercept at which the line actually passes through the axis, let's just say. So yeah, for example, for two consecutive values of x, so let's just say x2 minus x1, if they are consecutive, then this becomes x1 plus 1 minus x1. This basically is 1, right? So if this is 1, then m into 1 plus c is equal to y, right? So this gives us y is equal to m plus c. Now what is the value of c? C now equals to y minus m, right? So this is the value of c. So for example, if if x is equal to 0 or x is equal to xn minus xn, then c will become automatically y, right? So this is the value of intercept. So intercept basically acts as a bias because we want to move our line across the intercept so as to get the plotting better. For example, from the same point of interception I can draw another line, and similarly I can draw another line. But what we want to do is we want to find the best fit line. So if we're drawn by hand, this line seems to be better of all these three lines, right? So yeah, this intercept, given the intercept, we can actually move the line, or we can move from the same intercept so as to get the best fit line, which is our target.